Hi and welcome back to another LeetCode video. Today we're looking at LeetCode 3402, an easy problem, and it's about minimum operations to make columns strictly increasing. Right, so this is another interview practice video where I practice solving a problem using a structured approach. If you look at any of the other videos, you will see what I mean by that. Here I will just dive right into it. So we're given a matrix, M by N matrix, called grid, consisting of non-negative integers. In one operation, you can increment the value of any cell in the grid by 1. Return the minimum number of operations needed to make all columns of grid strictly increasing. Interesting. So I suppose, okay, I suppose first thing we want to know is whether a grid always contains elements or if it can be empty. And the answer lies in the constraints. So we have N and M, and both are larger or equal to 1, which is great. And all of the values in grid are between 0 and some other integer. Cool. So here's an example where we're given the grid. So we can see we're given it row by row. So this is row 1, 3, 2. Row 2 is 1, 3. Row 3 is 3, 4. The last row is 0, 1. Now we should make the column strictly increasing. And we can only add values. We cannot decrement values, right? So in order to make this column strictly increasing, probably have to iterate over all of the values over all rows for this specific column. And if a value is 3, the next value needs to be 4, then 5, then 6. Yes, we just need to need to increment the next number so that it is larger than the previous number. That's essentially what we need to do. And I think we can do that in one step. We just calculate the difference and add that. Cool. So, and the output would be the minimum number of operations needed. So we have to count our increments. So actually, let's do this with this example. So for the first row, well, we start with, I'm not going for the first column, right? So column 1. Let's say we're looking only at column 1. So we start with the value of 3. Then we have a value of 1. So what do we need to add to get 4? Well, we have to do a plus 3, and then the next value becomes 4. Now the value after 4 and the next row is 3. So what do we have to add to 3 to be larger than 4? Well, 2. And then this 3 becomes a 5. Next one is 0. What do we have to add to 0 to get a number that's larger than 5? Plus 6. So if we add all the pluses together, we have 3 plus 2 plus 6. So that's going to be 11, right? For the first column. And column number 2, what will that be? Well, we start with 2. 3 is already larger, so nothing to do. Then we get to 4. Great, still in increasing order. Then we run into a 1. So what do we have to add to 4 to get, well, what do we have to add to 1 to get 5? Well, we have to add 4, right? So we will have a plus 4 at the end. So that would mean that our output is 11 plus 4, which is exactly as expected, 15. So I think we've understood the problem. Here we have the same scenario, and it just does it per column. So I think I have a pretty good understanding of how that works. And, you know, I'll probably ask the interviewer some other question. You know, does it matter if the elements in a row are in order or not? And obviously they aren't here according to the problem description, but those are questions that I would ask. Now, I think we can solve this in, I guess, well, we have to iterate over all of the elements of the matrix. So we're definitely going to have an M times N time complexity. And we only need to keep track of, well, we only need to compare two adjacent numbers to determine how to update the next number. So we only need, I guess, O of 1 space if we update the grid in place. And yeah, we could update the grid in place. We could also just keep track of what the previous value was that we incremented to and then not change the grid. So I would ask the interviewer, is it okay if I update the grid in place? Right. And maybe it says yes, and that would be nice because it makes it easier. Or it says no, and then we have to some extra gymnastics with remembering what the previous number was, etc. So then next step is to ask them, are you okay for me to implement this? And then of course the answer is yes. And we're going to implement it now. So right, and we're going to implement exactly the way that we just solved it by hand. This is also the reason why you solve it by hand first before you start writing code, so that you have an idea of what your code should do. Even if it's just, I guess, a naive implementation, that's fine. You need to shell out one solution as quickly as you can. Don't try to shell out the smartest solution right away. It typically gets you into trouble, and it robs you of the opportunity to understand the problem well enough to actually come up with more efficient solutions later. Right, or even trade-offs with different solutions. So yeah, so what are we going to do? Well, we're going to iterate over all of the columns and all of the rows, right? So for x in range, well, we need the width and the height of this, right? So width, height, compute that really quick. So the width is, well, the width of the first row of the grid. This way, and the height is of course the number of rows in the grid. So that's just going to be length of the grid, right? So now we iterate over the columns, right? The x values for the columns. And in the inner loop, we're going to make sure that the elements in the column are going to be in strictly increasing order. So we do for y in range 8. And we know that the minimum value in any of these cells is going to be 0. So maybe initialize it with the min value being -1, so that we don't have to adjust the first value. Right. So now what we do, we get the current value from the current column, and we access it via our coordinates, row y and column x. And now we do a little check. If current value is smaller or equal than our min value, we could actually call this previous value, right? And we call this current value. Nice. If that is the case, well, that means we have to increase our current value by some amount. So, and the difference is what we have to add to our result. And I forgot to initialize our result variable. Result here, set to 0 in the beginning. And at the very end, we're going to return it. And now we calculate the difference between the current value and the previous value. Our current value is smaller, so we do previous value minus current value. And well, when they are equal, then the difference is going to be 0. So that's no use. So we have to add 1 if we want to make sure that we make current value larger than the previous value. So what we'll do is we'll do current value is equal to plus equals. That's all we need to do. And if you're a little bit paranoid, you can just put an absolute around this. So if you, but you don't have to, because you already checked which one is larger or not. But this prevents maybe errors. Cool. Right. So now what we have to do is we have to update what our previous value was. So that's just the current value. And next time when we go into the loop, again, when the next current value is smaller or the same as the previous value, we have to increment it by the difference plus 1. And yeah, we have to update our current value. That's all we need to do. So, and since we, after we finished iterating over a column, after we finished the inner loop, the loop with y, we start from the beginning. We set the previous value to -1 and the same dance begins. So I think that is everything that we're going to need. And yeah, let's just try it and see if the test cases pass. And we're getting the wrong result. That means we probably have an error some. We're not updating our result variable here. We have to add if, because that counts how many times do we have to add 1, you know, to ensure strictly increasing order. Cool. So it passes the 2 test cases. You're now going to submit it to see if it passes all of the test cases, and it does. And that completes this problem.